They are on their way, on the 1st. On April 1, 2026, at 6:35 p.m. local time, the Space Launch System, or SLS for short, left Launch Pad 39B at the Kennedy Space Center with nearly 4,000 tons of thrust. On board are the three NASA astronauts, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and the Canadian astronaut Jeremy Hansen. 4 people, 10 days, the first manned flight beyond Earth's orbit since Apollo 17 in December 1972. After a very brief 54-year break, there's finally a crew out there again. Be sure to stay until the end, because I have a very special treat for you. My name is Serwan, and this is Mars Chronicles. Let's start with what went well, and that was actually quite a lot. The launch itself was technically almost flawless. The fueling, which had struggled with hydrogen leaks during earlier wet dress rehearsals, went smoothly this time. The replaced seals held. The leak rate remained well below 1%. The permissible limit here is 16%. The Saturn V had similar tolerances in its time, but back then, nobody checked every single fitting like they do today. Some of you noticed that during launch, the emergency escape capsules were activated. The rocket flew the planned trajectory more precisely. The 2 solid rocket boosters, which provide 75% of the thrust at launch, were jettisoned after about 2 minutes, and the separation of the orange core stage was also nominal. We got these epic shots in the process.
We're seeing throttle down. Converb separation. Main engine throttling up, guidance converged.
If you look closely, you can see the nozzle extension of the RL-10 engine on the ICPS, which hasn't been deployed yet. The 4 solar arrays of the Orion spacecraft deployed as planned and immediately began generating power. Just under an hour after launch came the first real highlight of this flight day. The perigee raising maneuver was successful. The highest point of an elliptical orbit is the apogee, and the lowest point is the perigee. The apogee raising maneuver took place after just under another hour, and it was also successful. Both maneuvers together have placed Orion into a stable, highly elliptical Earth orbit, with the perigee at about 1,600 kilometers and the apogee at around 40,000 kilometers. This is the orbit from which the translunar injection burn, the crucial thrust toward the moon, will take place or has already taken place. So the crew is already on a transfer trajectory toward the moon when you're watching this. After these 2 orbital maneuvers came the proximity operations, or ProxOps for short. ProxOps was one of the most important technical objectives of this early phase of the mission. The maneuver tests Orion's ability to manually move relative to another spacecraft. For this purpose, Orion is equipped with navigation sensors and reaction control thrusters, but no GPS and no support. So the only thing estimating the distance to the other spacecraft is the crew member's eyes. Why is that important? Because on future lunar missions, Orion will have to dock with the Human Landing System from SpaceX or Blue Origin in lunar orbit, and there's no GPS there. The reference target was the ICPS, the Interim Cryogenic Propulsion Stage, which is the upper stage of the SLS rocket. This stage had previously brought Orion into high Earth orbit. It has been on its own trajectory ever since. The crew maneuvered Orion through a series of controlled approach and retreat maneuvers in a sequence lasting about 70 minutes. At a distance of 30 feet, which is less than 9 meters, they tested the fine control of the spacecraft in close proximity to another object. Victor Glover flew the maneuver. Wiseman went through the procedures. Hansen and Koch observed from the windows and checked with cameras. The result, nominal completion. Completely successful. After completing the ProxOps, Orion automatically performed a departure burn and safely moved away from the ICPS. The ICPS will then perform its own deorbit burn and enter the atmosphere over a remote area of the Pacific. Shortly after this ignition, the 4 small satellites located in the stage adapter between the upper stage and Orion were deployed at 1-minute intervals. But not everything went smoothly. Let's quickly discuss the mishaps. There were indeed some, and we need to talk about them honestly and objectively without dramatizing them. Shortly after the perigee-raising maneuver, ground control lost communication with Orion. This happened when the handover from launch control in Florida to mission control in Houston took place. For a few minutes, mission control couldn't receive any data from the spacecraft or the crew. The crew themselves could hear the ground the whole time, so the uplink was working, only the return link failed for some reason. The cause was a handover problem, meaning an issue during the switch between the Near Space Network and other ground stations. The team on the ground quickly identified and fixed the problem. Isaacman commented on it quite matter-of-factly during the press conference. During a handover, there can sometimes be strange configurations. You just solve it. It wasn't a system failure, but rather a teething problem of a new system. Not a single onboard system was affected, and the crew was never in any danger. Then the toilets. I'm saying this without irony because it's actually an important test objective. During the checkout of the onboard toilet, an error light came on. The crew reported it, mission control analyzed the data, and after the successful ProxOps demonstration, the crew and ground personnel troubleshot and fixed the problem together. That took a few hours, but the toilet is fully functional again. The same applies here. This is not a scandal. This is a test flight. The space shuttle had far more dramatic problems during its early missions. And that's exactly the point of this mission, to learn how Orion actually behaves with people on board, under real conditions, in real orbit. Isaacman summed it up at the press conference. We're happy to find issues. That's the job of this mission. All the analyses in the world can't replace a real test flight under actual conditions. If you like the video, feel free to hype it up now. That's the most important thing you can do to help more people see it. A like also helps a lot. And if you haven't subscribed to the channel yet, now is the perfect time to do so. Thank you. And now back to the things that didn't go quite so smoothly. But now I'm getting to the point that I have to talk about directly and bluntly. NASA has been promoting this moment for months. Artemis 2 is the first crewed mission beyond Earth's orbit in a generation. A historic event. And the world is watching. Or the world tried to watch. Until T0, the live broadcast was excellent. Professional and captivating. The commentary was informed, the camera angles were strong, the atmosphere was palpable. And then, right at the moment the rocket lifted off, the production collapsed. Cameras failed, strange cuts, and then the most unbelievable thing. In one of the most dramatic moments of the entire launch, the separation of the two solid rocket boosters, or SRBs, the NASA broadcast showed the audience on the ground. The audience that had come to see the rocket, not to be seen. While 4,000 tons of thrust propel a rocket into the sky and the SRBs separate in a fireball. One of the most visually spectacular moments in the entire history of spaceflight, the international broadcast showed people looking at their phones. And as if that wasn't enough, in the summary of the launch released afterwards, the booster separation is also not shown. In the official summary. Not present. That's embarrassing. And I'm saying that as someone who genuinely loves this program. NASA has been working for decades to send people back to the moon. Thousands of people have dedicated their careers to this moment. And then, at the very moment the world is watching, the production team fails so fundamentally that one of the most iconic shots of the launch simply wasn't shown. This isn't a technical failure, it's a problem with priorities. And NASA should address this publicly, analyze it, and do better next time, please. Because Artemis is not just about spaceflight, it's also about communication, it's about inspiration, and inspiration needs images. In addition, NASA is not a private company that isn't accountable to anyone. They are a publicly funded institution that owes everything to the public. After almost 2 days, another video was released where we got to see the booster separation from the rocket's perspective. At least. But billions of people don't watch such summaries anymore. Then there was a small software problem with Microsoft Outlook. It seems that two Outlook windows were open, but neither of the two windows wanted to work properly. Mission Control took care of it quickly and it was done in no time.
And I see that I have two Outlook windows and neither of them is working. If you could look at these two Outlook windows in Optimus, that would be great.
Alright, we will join in on your PCV. But what happens now? The crew took a short break after the ProxOps, a quick snack and a 4-hour nap. After that, another perigee-raising maneuver followed, which was also successfully completed. The next major goal was the Translunar injection burn, or TLI for short. This ignition of the main engine of the European service module took place about 24 hours after launch. In Central Europe, it was already the 3rd of April, around 2 a.m. Orion has now left Earth's sphere of influence and is on its way to the Moon. That was the critical commit point of this mission. There used to be options, but now there aren't any. At least not without significant additional effort. Before the TLI, the mission management team under John Honeycutt evaluated all system data from the last 24 hours. Life support, communications, propulsion, and redundancies. Everything was green, which meant a clear path toward the Moon. The TLI went according to plan and put Wiseman, Glover, Koch, and Hansen on a free return trajectory around the Moon. A trajectory that would automatically bring them back to Earth without any further engine maneuvers. Safety through orbital mechanics and physics. Brilliant. After the TLI, there was an interview with journalists that lasted about 20 minutes. The crew is doing well. They have big smiles on their faces and they're in great shape. And somewhere along this journey, on the 6th day of the flight, they will break Apollo's distance record. In doing so, they'll get to see some of the Moon's craters that were always in darkness during Apollo. For example, Mare Orientale. No human has ever seen this crater with the naked eye. The images of it were taken by satellites. An epic image has already gone around the world. It shows the Earth in all its glory from about 64,000 kilometers away. If you look closely, you can even see the greenish, shimmering aurora borealis at the poles. Absolutely breathtaking. That's only possible because the picture was taken on the night side of the Earth. In this case, the Earth is illuminated by the Moon. This allows the camera to capture even some stars and the aurora itself, without clouds and other parts of the image being overexposed. Whether it's a new Earthrise, you can't really say today. In any case, I recommend this video on the topic here in the end credits. My name is Serwin, and this was Mars Chronicles. Thanks for tuning in. Per aspera ad astra. Evaluate all system data from the last 24 hours. What? Evaluated.